The first type of chemical reaction we're going to take a look at is a decomposition reaction. What the word decomposition means is breaking down. So we're going to have a compound and we're going to break it into its elements. The compounds we're going to look at are copper 2 chloride, lead 2 bromide, mercury 2 oxide, and water. We are going to compile a table because the table is a nice way of comparing all of the information we get. And we need to have columns for reactants, appearance of reactant, appearance of product, and a balanced equation. So your table, once you've constructed it, will look like this. Press pause, make sure that you've got this table constructed before you start looking at the video material. Now, there are a whole lot of videos on YouTube that you can take a look at if you want to. I'm going to show you some videos which are enough, but if you want to, you can always take a look at more. So, the first thing we're going to look at is what happens to copper chloride when I pass an electric current through it. Now, the first thing is to realize that copper chloride is made up of copper ions and chlorine ions. In other words, it is made up of Cu2 plus and Cl minus. Let's take a look what happens when I dissolve copper chloride in water. So the copper ions and the chloride ions go into water and they then break up so that they are free to move around. And because of that, they can conduct electricity. You've got loose copper ions, and a copper ion, by the way, looks like this, Cu2 plus, and you've got loose chloride ions, Cl minus, in a ratio of 1:2. Now what happens is I pass an electric current through there, and we are going to take a look at what happens at each of the electrodes. That's called the anode. It's connected to the positive terminal of the cell. And what happens is electrons are moving in that direction. The chloride ions are attracted to the positive because they're negative, and they lose their electrons, and the electrons go off in the wire. At the same time, the chlorine metal forms. We happen to call this electrode the anode. We're not going to go into detail on anodes and cathodes, but the anode is the place where we are going, that is connected to the positive terminal of the cell, and it's the place where something called oxidation occurs. You don't have to worry about that. The next one is what happens at what's called the cathode, and at the cathode we are going to land up having chloride ions being attracted to the negative terminal. So in other words, the negative terminal of the battery is connected to this electrode over here. The positive Cu2 plus ions are attracted to that electrode. They gain electrons and they become copper metal. Let's watch an animation of that. There you can see the copper gaining electrons and becoming copper metal. And what happens is you get a deposit forming on the outside of that particular electrode. So this electrode, you would have bubbles forming, and they are bubbles of chlorine. They would smell a little bit like a swimming pool. And on this electrode, you would get a layer of copper metal forming. What's the equation? Well, first let's take a look at what did my reactants look like. My reactant was a blue liquid, and the products were it's actually, chlorine is a yellow, no, it's a yellowish greenish gas. Not that you really see that, but you would see bubbles. And then copper is a reddish brown metal. So that's the appearance of everything. The balanced equation is copper chloride with the help of an electric current is going to turn into copper metal, which is a solid, and chlorine, which is a gas, Cl2. Sorry, that's a plus sign. And this copper chloride is dissolved in water, so we say that it is aqueous. Let's check, are we balanced? 1 copper, 2 chlorines, 2 chlorines. Here again, we're now going to take a look at what happens if I pass an electric current through melted lead bromide. There are some YouTube videos, but I'm going to show you an animation that comes from Multimedia Science School. So, first one. Here is the lead bromide, and it is going to, that's the lattice, and when I heat it up, the lattice breaks up, and I get Pb2 plus ions and Br minus ions in a ratio of 1 is to 2. Those then are going to do the following. I'm going to have a cathode, which is connected to the negative terminal, which means it is a negative electrode. And over here, I would have an anode, which is connected to a positive electrode. Well, sorry, the positive terminal, so it is a positive electrode. If lead 2 plus is positively charged, it's obviously going to get attracted to the negative electrode. Br minus will be attracted to the positive electrode. And in each case, electrons are going to be transferred, and we are going to break up lead bromide into lead metal and bromine. Because it's hot, you'll end up actually getting a gas given off. Let's see what happens. So over here you can see that the lead ions, which are positively charged, are attracted to the negative. They gain electrons and become lead metal. The lead metal sinks to the bottom. Over here we are going to have the positive electrode. We get the bromide ions being attracted to that, and we're going to get bromine gas coming off over there. The reason it's gas, by the way, bromine is normally a liquid, but because it's heated, it actually turns into a gas. So what have we got? To start with, we've got this lead bromide stuff over here is just a white powder. So that's what we start with. We then melt it, and it starts to go a bit yellowish because some bromine already gets given off just by decomposition of heat. But it's white powder, and then it forms a silver-colored metal at the one electrode and a brown gas at the other electrode. Notice with decomposition that the reactant is completely different to the product. How do we balance that equation? We say lead bromide, it's lead 2 bromide, so it's PbBr2, which was a solid, but I melted it into a liquid, but it doesn't really matter what we do there. I pass an electric current through it, and I get lead, which is a solid, and bromine, sorry, that should be on one line, but Br2, which in this case, because of the heat, is a gas. But it's also, if you'd written liquid, it would be fine. So over here, you could have written solid. Over here, you could have written liquid. The phases aren't very important. What is important is that you decompose lead bromide into lead and bromine. If I decompose mercury by heat, mercury oxide by heat, it's mercury 2 oxide as well. And we are going to just play this video over here. Heating it, you actually will notice that you will produce some silver droplets and some bubbles of gas. Those bubbles of gas will cause a glowing splint to burst into flame. So what happens is my mercury 2 oxide, so it's HgO, breaks up, and as you can see, it's a reddish brown powder. Oopsie, sorry. And this here is a solid, breaks up into mercury, which is a liquid, and obviously the mercury is made up of a silver-colored droplets and oxygen gas, O2, which is a gas, and that is a clear gas that causes a glowing splint. To ignite. Again, notice that your reactants are completely different from your products in a decomposition reaction. What did I use to decompose this? It was simply decomposed by heat. Now you may wonder why we're not doing these experiments. I need to just remind you that both mercury and lead are what are known as heavy metals, and if you should inhale them or you should get them into your system, your body actually can't get rid of them at all, and you get something called heavy metal poisoning. And heavy metal poisoning lands up making people become a little bit mad. They first get the shakes, and eventually they degenerate into complete madness. And the reason for that is because heavy metals, if you take a look at a nerve cell, axons and dendrites are not actually attached to each other. they send little nervous impulses between each other. Ching, ching, ching. And what happens is mercury or lead will come and sit in what is known as the synapse space, which is the space between two nerve cells, and it interferes with your body's ability to send nervous messages. What that means is that you start to become quite uncoordinated, and eventually your brain can't even work and have clear, coherent thoughts any longer. So I avoid coming into contact with mercury and lead if I can possibly help it, and that's why I'm just showing you videos of those. The next one we're going to do is we're going to pass an electric current through water, and water breaks up with using an apparatus called Hoffman's apparatus into oxygen and hydrogen. So we have got water. We all know what water looks like. And it breaks up into, with the help of an electric current, it electrolyzes into hydrogen and into oxygen. And we just need to balance that. That's a liquid. This is a gas which causes a flame to go pop. And this is a gas that causes a glowing splint to ignite. Let's just take a look at what happens when we do that. You can see here that this is an animation and gases come off at both of them. And what happens is, sorry, my video stopped working, is we've got bubbles that are given off. Take note that we've got double the amount of one gas and half the amount of the other gas. And that makes sense because I have 2 hydrogens for every 1 oxygen. So over here would be hydrogen given off, and over here would be oxygen being given off for the electrolysis or decomposition of water into its constituent gases.